Hello everyone. So today we will be talking about distribution of random variables. I will try to give you some highlights and I prepared two examples for discrete random variable and how we can actually find the probability and then the probability distribution, the table we saw before, and then I will also talk about how we can create joint probability distribution and how we can actually look at all the properties in a probability distribution and in the joint probability distribution. So we will be talking about at first what a random variable is. So previously we talked about, let's say we have some we have an event, we are rolling a dice or tossing a coin. So in those events, though the outcome we have from an experiment, if I'm tossing two coins, then what would be the probability that in both coins it will be head? So that means I have an objective and then I have an experiment, I have an outcome. So from that experiment, the outcome we are getting, it could be head or it could be tail. We don't know. There might be some possibility that head will occur. The possibility might be 50%. If we are tossing two coins, then what might be the possibility of getting two heads on both coins? So that means the outcome we have, we are calling them random variable. So if the variable is discrete, then we are calling them discrete random variable. In case of continuous continuous variable, then we will talk about the continuous random variable. So today we'll more talk about the discrete probability and the discrete random variable, the discrete probability distribution, and then I will walk you through using an example. So in this example, you can see that we are tossing three coins. If you toss three coins, last time I told you that you can actually draw some tree diagram. It might be easier to see what are the outcomes we have, but you can also create and then write down what might be the outcome from those three coins. The probability distribution, because we thrown three coins, the random variable we have, we need to define it first. The random variable, I'm saying that my interest was the number of heads. So that's the random variable I'm talking about. If I toss three coins, then it could be head, head, head. It could be head, tail, head, or other possibilities. The number of heads is my random variable here. So let's show you how can I actually create this probability distribution given that we have three coins we thrown and given that the number of heads is our discrete random variable. So over here you can see that I'm trying to find the discrete probability distribution. So in the example, we have our experiment, we have our random variable. We define our random variable using a capital letter. So we say that the number of heads is our random variable. The possibilities we have, you can see I wrote down all the possibilities. You can draw the tree diagram I showed you before. And then from there you can see we could have head, 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 or tail, 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 or head, tail, tail. That means there are 8 possibilities we have. So the probability we have for each of the values, that means we have to think about how many heads can be there in 3 of those whenever we toss 3 of them. That means we could have, if we throw 3 coins, we could have the number of heads in all, number of heads in none, maybe number of heads in 2 places, number of heads in 1 place. That means the possibilities of those heads in those all possibilities, what can be. Then we define that this is the general one. So the probability would have the combination of, in total, how many outcomes we can have. So you can see that the head can be only come in 0, 1, 2, 3. That means up to 3. So in here n would be 3, and then choose in each of cases 0, 1, 2, and then the 2 power, in total it would be 3. So that's why 2 power 3. So you will see that over here I mentioned it, n is 3, probability would be 3, choose each of those probabilities. So I wrote it wrong in here, so it should be, yeah, it's good, 2 power, it should be 3, and then 2 power 3, because n is 3 in here. So that's why you can see that the discrete probability distribution we have for the random variable x, the random variable we already defined, is that we could have 0 outcome, we could have 1 head, 2 head, 3 head. So in each of those cases, what would be the probability? So you can see that I try to find what would be probability using this equation. So the x is 0, that means 3, choose 0, divided by 2 power 3, that means 8. So that means it would be 1 over 8. Same thing, you can do that. 3, choose, the x is 1, 3, choose 1, divided by 8. In each of those cases it should be divided by 8, only the numerator will be changing. Now we want to find what might be the expected value, that means the average value, given that we have the outcome and then we have the probability associated with it. So the expected value would be each of those random variable value multiplied by its associated probability. So that means every time you have to multiply by the variable value, 0 multiplied by probability, 1 multiplied by the probability, 2 multiplied by this probability, 3 multiplied by this probability, and sum them. So that's what I try to do. You will see that in here the probability I try to find using the equation here, and then we need to sum them so that we can find what might be the expected value. That means the mean, that the probability we are looking at is the random variable of x would be the number of heads. So you can see the probability value, since we use the random variable value and the probability, that it would be 1.5. That's what we try to show you in the lesson. So you will see that mean of the discrete random variable, so mathematical expectation actually for them. So you can see that's the equation we used, and we can generalize them so that we can find the for a new variable, the new random variable, how can we define them. And then I will try to show you how we can find the variance as well. So for the variance of the random variable, so we will try to use this equation. These are the if we derive them, you will actually find the variance would be this, using this equation. This one would be easier for us, but we can also generalize them. Okay, so let's go back where we were at. Then you can see that for us, we are using the equation I showed you. So we have to use the probability distribution table we have, and then using this probability distribution, what we are trying to use is that the random variable values, square them, and then multiply it by its associated probability. But after getting the sum, then you also need to subtract the mean squared value. So that's what I try to show you here. So you can see that every time I try to square the random variable value multiplied by its associated probability. And then if you sum them, then you will see that I sum them, all of these values. You can use your calculator. It doesn't necessarily that you have to use Excel. It's easier for me to show you, that's why I'm using Excel. So you can see that I actually use the mean value to subtract from the sum so that I can get the variance of the random variable. You can also find the standard deviation of the random variable just by taking the square root of them. Now my question to you is how we can find the probabilities if it is random variable value is more than 0. So random variable value, so you can see in this table, if it is more than 0, that means we are talking about the probabilities. If it is random variable value is 1, 2 or 3. If you sum them, then we can get the probability if it is more than 0. If it is exactly 0, the probability would be 0.125. If it is less than 3, then we need to add these 3 values. If it is at least 3, so that means you need to consider which one. Think about it. So many times you will see that we are talking about finding the probabilities. If it is a discrete random variable, then you can easily find using the table you have. So we just talked about if we have one random variable, then how we can find the probability distribution and then find the expected value and then variance from there. When we have two random variables and they are associated and then joined, that means if we change one, another might be changing or may not, then we have to think about how we can find the joint probability distribution. So that's what I will try to show you using an example. There are lots of examples available in the textbook. Try to solve them. So let's show you using an example. So in the example, what we will try to do, we will try to see whether these two random variables we have, whether they are independent. That means if one changes, another changes or not, whether there is any association among them. And then similar to what we saw in the one random variable, whether we can actually find the mean and then variance, and then whether we can find the covariance between those two variables. So the detail example, detail variance and the expected values, how we can find them, all are given in the textbook. So we are trying just to give you some highlights in here. So for the other one, let's show you. So you can see I just added an example, joint probability distributions. I say that suppose that we have two seedlings that we are randomly choosing without replacement from 12 seedlings. That means we have altogether 12 seedlings. We are only choosing through two from there. So but we have in those 12 possibilities, 12 seedlings, we have 3 white spruce, 4 black spruce, 5 jack pine. We have altogether 12 of them. So I'm saying that the let's say the since we have more options, let's define them. So I say that I have two random variables. First random variable is that X is the number of white spruce chosen from these seedlings. Y is the number of black spruce. So we are not giving any event name, giving any random variable name for the jack pine. So we have these two random variables. Okay. So we are interested about all these. So you can see that I'm interested to find the joint probability distribution and then the marginal probabilities. So I'll talk about that, and then whether they are independent, those two random variables. How about their covariance? If they're not independent, you will see that they should have some covariance values. And then if we have the constant 3, if we want to find the expected values, then how we can find them, and how we can find the expected value of x multiplication of y. So depending on whether it's independent or dependent, we have to choose one of these equations. How we can find the covariance of these two variables. I actually talked about it in here, but I had it in number 7. That's fine. Okay. So at first, we want to find the joint probability distribution. So I try to give you the equation we are going to use. Similarly, we used previously only, since we had only one random variable, we just use the one random variable. Since we have more than one, so we have to think about all of them actually combined together. So the total possibilities, you have to think about it first in the denominator. So we have 12 seedlings, and then we are choosing 2 from there. That's the constraint we have. And then since x is the white spruce, we have possibilities of 0, 1, 2, 3. Y is the black spruce, and we have up to 4. So that's what I did in here. 3 choose x, that means white spruce, black spruce, and the rest is coming from the jack pine. If we never had jack pine in there, then we don't need to add them. Since we are talking about we are only choosing 2, then how many we already chose from white spruce or black spruce? If we already chose 2, then these will become 0. So it might be helpful for you if I show you in this example. So you can see that using this equation, I'm trying to find the white spruce is 0, 1, 2, 3, and then the black spruce is 0 up to 4. So whenever I will give you any situation, you need to think about what would be and how many random variable values are there. Then you can draw them. So I try to draw them. And then we can only choose 2 because we are saying that we can only choose 2 from that experiment. So you can see that if we have white spruce is none, black spruce is none, that means the rest is coming from jack pine, since we should have 2 seedlings in each of those cases. This is a possibility. We could have one black spruce, white spruce 0, but the other one should come from the jack pine. So you can see I added the marginal. So whenever we will have all the probabilities, then we can add them together. That will be the marginal value for whenever we have black spruce 0. So that means for 0, 1, 2, 3, 4, we will have marginal values if you sum them. Okay. So over here you can see that I colored them same. So I think that means whenever we have 0 white spruce, 0 black spruce, and then jack pine would be 2 because we are not choosing anything from white spruce, black spruce. Then if it is 2 jack pine only, so you can see that I added only 2 jack pine, and then the total possibility should be divided. That means the 12C2 divided. That means it would be 66. So you can see 10 divided by 66. How about the next one? So you can see I'm showing you another one where we have the black spruce 2, white spruce 0, and then since we already chose 2, we cannot have anything from jack pine. So that's how I calculated. How about the red one? So you can see the red one, I couldn't find anything because we say 2 white spruce, 2 black spruce, and then the rest can be jack pine, but it's not possible because we are only choosing 2. We cannot have 4. That's why in many places you will see that we cannot have any value. Also, sometimes students make mistakes. They say that whenever we don't have any value, let's add 0. 0 means there is a possibility, but there is no possibility that we will have 2 white spruce, 2 black spruce. So in many places you will see that you can keep it just blank, or you can say not available, not possible. Okay, so I try to calculate the probabilities, and then for each of those cases, so you can see that these are the places where it's not possible to have any probability. That's why I kept them blank. So whenever we have all the probabilities in the table, then you can see marginal values you can find just by adding them. So I just added all these values to find the marginal value whenever we have the black spruce 0, 1, 2, 3. Same thing for the white spruce. So we have only 3 marginal values for white spruce, so you can say sum them. So we have our table. So do not leave it just like that. Try to find the values itself. So you can see the values are added in here. So you can see I gave you the decimal values. You can keep up to 2 or 3 decimal values. And then, so I said that I would like to know in the whether they are independent or dependent. So in each of those values, if you see the, let's say in each of those cell 0.182, so if I take that value, the joint probability value, and then what's the marginal value for that, these two are the marginal value for 0.182 for that cell, then you can see that if I multiply these two marginal values, it's not possible to get the joint probability. So that's the joint probability, that's the marginal probabilities we have. So in each of those values, you can see that if it's not possible, then we say that they are not independent. That means they are related. And then how we can find the expected value? So you can see that to find the expected value, what we have to do is that we have to use the table, the marginal values we have. So each of those marginal values you have to multiply by the associated probability. So you can see the marginal values I got from before, I multiplied by the associated random variable value and then sum them together to find the expected value. Same thing for the expected value for black spruce. And you can see that I added a equals 3, that means the constant. We already know the expected value of x would be 5.5 and then 667. So I added them and then find the expected value for x plus a y. Similarly, so you can see that in another way we can say they are independent or not. So since they are not independent, whenever you try to find the expected value of the x and y, that means two random variables, then you can use this equation. This equation is simply what we have over here. So that means each of them, so all you need to do is to let's say 0.152 multiplied by 0 and multiplied by 0, 227 multiplied by 0 multiplied by 1. So that way for each of them you can find it. So I found that if I use the probabilities value and then random variable value, then the expected value of x and y is 0.18. Okay, so the covariance, for the covariance you can use this equation. That means the expected value of what we found for the joint x and y, and then their mean, that means expected value of x multiplied by expected value of y. So that's what I found if I multiply them and then subtract from the 0.182. That means if one increases, another decreases, and they are actually associated. So similarly, you can find the covariance that I showed, and then you can actually find all the properties of mean and variance. So you can see over here, so we have, I actually showed you expected value of the, if we have any constant, and then you can easily find the if we have any constant, and then if we have the if we want to find the addition of these two expected value, or subtraction of them, or multiplication of them. Okay, so later on I will talk about, in the other video, in the next lesson, I will be talking more about the continuous random variable. So that's about the lesson 3. But then again, I didn't go through much detail about conditional, the continuous probability distribution, since we are going to talk about it in the other lesson. Thank you all.